All right, we're getting back to our guitar build. In the last episode, we made our templates, and we know all of the design shapes and sizes. In the next 3 videos, we'll be making the basic components of the guitar into their final form. So in this video, I'll be working on the neck blank. First, we're going to cut a scarf joint. The idea of a scarf joint is you cut an angle, you flip the board over, and that gives a way for the strings to break over the nut, get some tension on the nut, and then the headstock is at an angle. Once we have that scarf joint, we'll also route a channel for the truss rod. We'll add some wings to make the headstock wider. We'll cut the headstock shape and we'll drill the tuners. And that's about it for the basic neck blank. That's what we'll do in this video. All right, let's get started.
First thing we're going to do is mark out our template on the neck blank. I marked a center line on the blank, clamped the guitar neck template down, and traced it with a heavy pencil. You want to leave plenty of room on the blank at either end of the template because we'll lose a little bit of length when we do the scarf joint. So it's good to leave 3-4 inches at either side. To do this scarf joint, we'll be using this jig that I built probably 15 years ago. It's a simple router sled that's angled at about 13 degrees. Different companies do different headstock angles. 13 seems to be somewhere in the middle. Over the years, I've cut this a few different ways. I've really grown to like doing the rough cut with a handsaw because I can slowly cut it and watch the lines and take my time. And then I'll use that router sled to go back and clean up the surfaces. Here I'm using a block to keep my saw somewhat square. And if you watch the line in the front, you'll see that I'm sawing down and slowly checking that I'm sticking with the line. This doesn't have to be perfect, but any imperfection is going to have to either be sanded away or routed away. So the closer you are, the less work you have in the next step. We can then flip the neck blank over and you see how the scarf joint takes shape. Even that rough cut gives us a pretty clean 13-degree angle, but this jig is designed to make it much more exact. The idea is we want to clamp the two pieces on top of each other and then route and sand a perfect 13-degree plane across them. So then when we flip it over, there'll be a nice seamless joint. I use a handheld router with a large base and just skim the top of the wood to give a nice even plane. And straight out of the jig, it looks pretty good. It's a tight fit. The angles look good. But I did decide to just touch it with some sandpaper on a slab of marble to give a nice smooth finish. This is probably about 220 sandpaper, something like that. I don't know if I've ever talked about these scraps of marble, but if you go to a marble shop, you can get some offcuts, and they work great for flattening jigs. Now, clamping a scarf jig can be really challenging. Everything wants to move in all 3 dimensions. I found the best way to do this is clamp it against a marble slab. That way nothing's going to move in the up and down direction there. I clamp the neck in place so it doesn't move. Then I get the headstock ready to glue up, get it pretty close, and lock it down as well. So now I know that these 2 pieces are aligned in the long dimension. And I've clamped them so they won't slide left to right. And that way I can really apply the pressure to that scarf joint, and there's no way for that slippery 13-degree joint to slide either way. There are many other ways to do this, but the real challenge is that wet glue is slippery, and clamping at a 13-degree angle, they really want to slide apart. I find that this works pretty well. Here's a shot of the clamps. Can never have too many clamps. We let that dry overnight, come in and unclamp it. It looks like a pretty tight joint. Next, I retrace the neck template onto the blank, just to know how far down the headstock goes. And I did a quick skim pass of the whole surface to make sure it's nice and level. I built mini guitars before I had this joiner, and on those I would just sand it until it was nice and even. If you lined up your scarf joint right in the gluing process, it really doesn't take much material to make it nice and even. I also ran the headstock part of the neck over the joiner, just to make sure that's nice and square. And for a third time, we're going to mark the center line and redraw the neck template onto the neck blank. That center line is necessary for us to route a channel for the truss rod. This truss rod happens to be about 6 millimeters wide, and the long part, I found a router bit that was 6.3 millimeters. I'm sure that's some standard imperial measurement. And the wide part where the nut is was about 9.4 millimeters. I found a router bit that was 9.6 millimeters. It's close enough. I will comment that as much as possible, I try to work in metric. You know, adding 0.5 millimeter, adding 3 millimeters is much easier in math than trying to add 1/64 to 3/8. It just makes much more sense to work in millimeters. But when you're working with router bits and drill bits, you kind of have to do your best to interpolate between the two measurement systems. To route the truss rod channel, I got a fence set up so that the bit would hit the middle of the neck. I nicked it at first just to make sure it was hitting right in the middle. And then we take a pass, just a few millimeters at first, to make sure everything is lined up. I'll also mention you have to mark on the neck how far down you want to go. The truss rod doesn't go all the way down the neck, so you have to stop at some point. The way I do that is I mark a line where the bit is on the fence. You can probably see it in this shot. And then if you look at the bottom there, I also mark a line where I want to stop on the neck blank. And I just push the blank across until those lines line up. Hopefully that made sense. Here I've raised the bit a little bit, and I'm taking another pass for the truss rod channel. This is the narrower 6 millimeter channel that most of the rod sits in. It took one more pass to get the channel to the right depth so the rod sits in there flush. You don't want it too deep because then the rod may rattle, and you don't want it too shallow because then the fretboard can't sit flush. After that long 6 millimeter channel, I change out the bit to a wider bit. This is the 9 millimeter bit that allows for the nut of the truss rod to fit down in the neck. So just as before, I mark how far into the neck I want that cut to go, and I push the neck until that mark lines up with the fence, and take it off. You can see how the fatter part of the truss rod fits into this wider channel. And in this particular case, there was a little bit of a pivot point there, it needed to be slightly deeper in one specific spot, so I just used a file to knock that down a little bit. Then the truss rod fit in very nicely. Now that the truss rod slot is routed, we can cut the extra material off the headstock side of things. And we're going to use that scrap to glue on some wings. The whole purpose of the wings on the headstock is that the neck blank is not wide enough for the headstock design of this guitar. So I need to glue on a little bit of maple to each side to accommodate the headstock design. To joint these, I clamped them together and used some marble to sand them flat. This was not my greatest joint. I was kind of in a rush. Looking back on it, I would have used a hand plane to make that a little bit better joint. And I knew at the time it wasn't a perfect joint. I should have taken my time. But once both of the surfaces are prepped, we glue them, apply some clamps, clean up the glue out of the joint, let those sit for 12 hours or so. And then we come back and do the same to the other side. You'll note that we routed the truss rod channel first because we had that nice long straight side to guide on the router table. If you attach the wings before you routed the channel, you wouldn't have that nice side to reference. This is a good example of thinking through all the steps of building a guitar before you paint yourself in a corner. With the wings glued up, we're going to once again trace our headstock pattern onto the neck blank. You can see how those wings give room just for the tiny horns of the headstock. And we're going to have to thin out the headstock. I'll talk about that in a minute. But before I do that, it makes life a little bit easier if I cut away some of the excess with a jigsaw. And then I sanded the headstock wings down to the same level as the rest of the headstock. I'm going to mix some units here, but a typical neck blank is about 3/4 of an inch thick. But a typical tuner can only reach through about 15 or 17 millimeters. So what we need to do is to thin out our headstock. Right now it's 19.5 or so millimeters. We need to thin out that area to about 15 millimeters. I do this with my router jig table. I clamp down the neck. Most of the time is spent figuring out how to clamp these things down in a way that the clamps don't interfere with the router sled. Then I clamp down some MDF as rails. And I take a few shallow passes, measuring as I go along until I hit about 15 millimeters in headstock thickness. If I remember correctly, I did this in about 3 passes. And in the end, the headstock, it's about 15.5 millimeters. I'm gonna have to do some sanding as I finish it, so that'll dial right into 15 millimeters. And the tuners will fit really well on that thickness. Next, we're going to drill the holes for the tuners. If I'd really thought this through, I would have put a center mark on those tuner holes in my design. But since I didn't do that, I went through and marked with a ruler the center of each of those circles. Went over to the drill press and put a small hole in the center of each of the tuner holes. Then I countersunk 3 of these holes. The idea here is that I will screw this template onto the neck blank directly, and that way it won't move at all while I route out the shape. I thought about how to do this for a while, but I finally decided that I should use that as a drilling template as well and just put a small hole straight into the headstock instead of trying to mark them with a pencil. Just drilling straight through seemed like it was less chance of some kind of drifting in the drill bit. So like I said, I have 3 screws countersunk in there so they're flush with the top. And then I can work on shaping the headstock itself. I start at the bandsaw just to get some of the bulk out of there. You don't want to route away much wood, so it's good to rough cut it first. And especially on a headstock, when you're routing this, you're going against grain and with grain and uphill and downhill, and there's a really high chance you're going to get some kind of tear out. So I recommend going very slowly with the router bit. I rarely get much wood tear out with a router bit, but this headstock step is the most likely to get some tear out. So pay attention which direction you're going, take really light passes, just take your time. There's the finished shape. We take the template off, and you'll see we have the 6 pilot holes and a nice headstock shape. This shot reminds me that the reason I like this scarf joint on the neck is I can get a truss rod adjustment wrench just straight onto that truss rod and adjust it without even having to move any strings. It's really handy, and I adjust my truss rods quite a bit. Final step here is to widen the holes for the tuners. I forget the diameter of these holes, but it's really particular to the tuners that you bought, so make sure you measure before you drill. They're not all the same. I designed this headstock to be pretty compact. I like a lightweight headstock, and I was kind of worried that I'd packed the tuners in too tightly. There was almost no tolerance in the design. So I was relieved to see when all of the tuners went in, and I'll get a close-up shot here in a minute. You'll see they are as close as can be, but that's how the design came out, trying to keep the headstock small, trying to keep the string path straight. Here's a final shot of the neck. It's ready for a fretboard. Again, we cut the truss rod channel, we glued on some wings for the headstock, we thinned out the headstock, we cut the shape of the headstock, we installed the tuners. Next step is to get a fretboard on it, but it's looking good. Hope that helps someone. Thanks for watching.